Okay, today we're going to be looking at our first example that has two quantitative variables. Up until now, all the examples that we've done all only had a single quantitative variable. And because of that, we had lots of choices for graphs that we could have used. When we have just a single quantitative variable, we can use dot plots, histograms, stem and leaf plots, box plots. All the graphs that we've done, we have so many choices because all we have is a single variable. But when we have two quantitative variables, the only choice for a graph that we have is a scatter plot. And the scatter plot tells us the relationship between the two variables. You want to avoid any statements about cause and effect. Remember, cause and effect can only be determined when you have a well-designed, well-controlled experiment. And that's not what we're going to have in this chapter. In this chapter, we're just looking about associations or relationships between the two variables. So in this case, we're looking at the amount of time it takes students to run a 40-yard sprint and how long they can do a long jump after they do the sprint. So if we think about it, the sprint is what is going to have a change in the long jump distance, because the longer and the faster they sprint, the less energy they'll have for their long jump. So it seems reasonable that the relationship for the long jump has been somehow altered by the amount of time that the students sprint. So the sprint we're going to call the explanatory variable. We always call the horizontal axis the x-axis, and in statistics we're going to call it the explanatory axis, and that's where the explanatory variable goes. So in this case, it's sprint time. So we're going to go ahead and label the horizontal axis sprint time, and the units is seconds. Now if we take a look at the sprint time, the sprint times for the 40-yard sprint, we see that it goes down as low as a little bit more than 5 seconds, and it goes up as high as about 9.49 seconds. So I think that if we label our explanatory or horizontal axis starting at 5 seconds, and for every half second, it'll make it easier to graph. So for every half second, we're going to put a little tick mark. So we have 5, 6, 7, 8, and 9, and the last mark is for 9.5. Now we have our vertical axis that we have to think about. The vertical axis is going to represent the response variable and is going to be marked along the y-axis. So this axis is going to be our long jump distance. I'm going to turn the paper to make it a little bit easier to write. And that distance is in inches. Now, for this variable, it looks like it goes, the number of inches that the students were able to long jump were as low as about 48 inches, but they went about as high as 184 inches. So if we mark our axis on the y-scale every 10 seconds, and if we start at 40, we should have enough to be able to graph the whole thing. Now I'm going to not number every other one. In fact, I'm going to skip every other one as I do my numbering. So, and I would recommend that you do the same. So we have 40, 60, 80, 100. 120, 140, 160, 180, and then that would be 190. So that would be perfect. Our next step is to graph each sprint time and its associated long jump distance as an ordered pair. Now you should remember how to do this from back in your Algebra 1 and Algebra 2 classes. So the first point, representing the first distance that was jumped by the student after he ran a sprint of 5.41 seconds. So 5.4 is almost 5.5, just a little bit lower, and we go up to 171 and put a point. So I'm going to mark it using my ruler. That way we make sure that we get it fairly accurately. And that's going to represent our first point. So now what I'm going to do is I am going to pause the video while you go through and graph the rest of the points in this same fashion. All right, welcome back. Now that you've finished graphing your scatter plot should have looked something like this. It doesn't have to look exactly like this one, but it should be kind of close. And that's what we have for today's example. Thank you, and I'll see you in class.